welcome to putting all of the rules together. So we have seen a variety of differentiation rules. So going through them, we have our power rule. Which says that if we take the derivative of x to the n, we get n times x to the n minus 1, again for n an integer. We have our product rule. Which said that if we wanted to take the derivative of f of x times g of x, we wound up getting the derivative of the first f prime of x times g of x plus the first f of x times the derivative of the second g prime of x. We had our quotient rule. Our quotient rule said that the derivative of f of x divided by g of x wound up being the derivative of the first f prime of x times g of x minus the first f of x times the derivative of the second g prime of x, all divided by the denominator g of x squared. We had our chain rule. Which we have seen in a few formats. So if we wanted to take the derivative of g of f of x, we did the derivative of g with respect to f of x times f prime of x. We also saw this as the derivative if we wanted to take the derivative with respect to x of, say, g of u, we did g prime of u, the derivative with respect to u, times the derivative of u with respect to x. Beyond these, we had some special derivatives. So for special functions, we had all of our trig functions. So we had that the derivative of sine of x is cosine of x. The derivative of cosine of x was negative sine of x. We had the derivative of tangent of x was secant squared of x, and the derivative of cotangent x was negative cosecant squared of x. We had the derivative of secant of x was secant of x times tangent of x. And I need to give myself a little more room. We also had the derivative of cosecant of x was equal to negative cosecant of x, cotangent of x. There were all of our trig functions. In addition to this, we have that the derivative of e to the x was simply e to the x. The derivative of natural log of x was 1 over x. And we learned this section that the derivative of b to the x was equal to the natural log of b times x, times b to the x. For b greater than 0 and b not equal to 1. So we now have a full series of derivative rules in addition to those that we had seen previously with our derivative of a constant, etc. But these are some to keep in mind. So if we want to say find the derivative of f of x equals 2 to the 5x squared plus 4x minus 1, we can recognize this as a composition. We have an outside function of 2 to the u, we'll say, and an inside function of u equals 5x squared plus 4x minus 1. So at this point, we can go ahead and use the chain rule. And we get that f prime of x is equal to the derivative with respect to u of 2 to the u times the derivative of u with respect to x. Well, we've seen the derivative of any exponential with a positive base. The derivative of 2 to the u was simply natural log of 2 times 2 to the u. And then we are multiplying by the derivative of u with respect to x. Our u was 5x squared plus 4x minus 1. We can go ahead and plug that in. So we have this as the natural log of 2 times 2 to the u times the derivative with respect to x of 5x squared plus 4x minus 1. We still need to do this derivative at this point. Now we can just do derivative of a polynomial using the power rule. Technically, we're also using the sum and difference rule. So we have f prime of x is equal to the natural log of 2 times 2 to the u times 5x squared. We would pull that 2 out front. It becomes 5 times 2 or 10x. Derivative of 4x is 4 and derivative of -1 would be 0. And so this is what we wind up getting as our derivative. Now let's go ahead and do one more. Let's find the derivative of g of x equals e to the 2x minus 1 times sine of 3x plus 2. So when we take the derivative, you want to kind of think of it as unwrapping a present. You want to work just like when we're solving an algebraic equation, you kind of work your way outside in. We're going to work with the very last operation to be done. So in this problem, the very last thing to have been done would have been the product. Right? So the product is the last thing we would do when evaluating. So it's just where we will start with our derivative. So this is again the last operation when evaluating, so it's where we should start for the derivative. So we start off using the product rule. So I'm going to go ahead and just rewrite this function down below. So we had g of x equal to e to the 2x minus 1 times sine of 3x plus 2. So the product rule says that g prime of x is equal to, we do the derivative of the first. I'm going to do my color coding once again. So we need to take the derivative of e to the 2x minus 1, multiply by the second, sine of 3x plus 2. Then to this whole thing, we will add the first, e to the 2x minus 1. And then we multiply by the derivative of the second. So we'll take the derivative of sine of 3x plus 2. So again, I still need to take two derivatives, and both of these derivatives require the chain rule. So let's do this one first, the e to the 2x minus 1, and then we will worry about the other one later. So in this case, my outside function is e to the u. My inside will be u equals 2x minus 1. And then we'll worry about the other one after the fact. So we're going to use the chain rule. So we have g prime of x is equal to, we'll do the derivative with respect to u. Of e to the u. And then we will multiply by the derivative of u with respect to x. And that is still multiplying sine of 3x plus 2. To all of that, we are adding our e to the 2x minus 1 times the derivative with respect to x of sine of 3x plus 2. So again, I'm holding off on the second derivative just so you can kind of see them individually, and I'm not doing too much in one step. When you do these problems yourself, as you get more comfortable with the derivative, you're going to be skipping some of the steps I write, and you're welcome to do multiple derivatives in one go. I'm just kind of trying to break it down so it's easier to follow. So at this point, the derivative of e to the u is simply e to the u. And then we have times du dx times sine of 3x plus 2 plus e to the 2x minus 1 times the derivative with respect to x of sine of 3x plus 2. From here, we're going to go ahead and plug back in. So our u was 2x minus 1. So we have e to the 2x minus 1 times the derivative with respect to x of 2x minus 1 times sine of 3x plus 2 plus e to the 2x minus 1 times the derivative with respect to x of sine of 3x plus 2. At this point, for that first chain rule, all we need to do is take that derivative of 2x minus 1. Well, there we just have e to the 2x minus 1 times 2 times sine of 3x plus 2. Plus, now we have e to the 2x minus 1 times the derivative with respect to x of sine of 3x plus 2. Now let's go ahead and focus on the second derivative that we needed to take. Our outside function is going to be sine of v. Our inside function is v equals 3x plus 2. So we have g prime of x is equal to e to the 2x minus 1 times 2 times sine of 3x plus 2 plus e to the 2x minus 1 times, chain rule says we do the derivative with respect to u of u, sorry, derivative with respect to v, I apologize, of sine of v and then we should multiply by the derivative of v with respect to x. I'm going to go ahead and rearrange this first term to be 2e to the 2x minus 1 sine of 3x plus 2. Then we have plus e to the 2x minus 1. Derivative of sine is cosine, so we have times cosine of v times the derivative of v with respect to x. Well, v was 3x plus 2. So if we plug that back in, we have 2e to the 2x minus 1 times sine of 3x plus 2 plus e to the 2x minus 1 times cosine of 3x plus 2 times the derivative with respect to x of 3x plus 2. We are almost there. We just need to take that one last derivative. The derivative of 3x plus 2 with respect to x is simply 3. So we have 2e to the 2x minus 1 times sine of 3x plus 2 plus e to the 2x minus 1 times cosine of 3x plus 2. All of that times 3. And if we rearrange, we have 2e to the 2x minus 1 times sine of 3x plus 2 plus 3e to the 2x minus 1 times cosine of 3x plus 2. So again, this was using that product rule first, and then both components of the product rule required us to then use the chain rule as well. So I realized I forgot to state up here that we are once again using the chain rule. So we use the product rule first, and then we use the chain rule on two separate things. Again, as you get more comfortable with these, I am sure you will skip steps to a lot of these faster. When I take the derivatives myself, I don't write probably half the steps that I write in these videos. So as you get more comfortable, you're welcome to kind of skip a little bit of what we write, but do make sure you keep track of where you are in the problem. It's easy to make mistakes and forget what derivatives you still have left to take.